All right, let's take a look at now at number 22 in this ACP review. It says the graph of a piecewise function is shown. What statements describe the discontinuities in this graph? And so as I take a look at it, remember there are three types of discontinuities. We have in alphabetical order, you would have an infinite, and that's where the graph at the break will take off and go to infinity. That's one type of break. You have jump. That's where the graph will jump from one y value to a new y value. And then you also have removable, where for all practical purposes, the graph may look pretty continuous, but there's just one small circle that's missing, just one point missing from the actual graph. Okay, so as we look at this graph from left to right, the first discontinuity we come to is here. This is the first time the graph breaks apart. It looks like it's an open circle there. It looks continuous, but it's just one open circle. That's what we'd call removable. And it happens at this x value of, appears to me to be -3. So we have a removable discontinuity at x equals -3. And let me change that to an @ sign. We have removable at x equals -3. Now, as we continue on, moving from the left to right, we come to this spot here at the x value of 3. And notice how the graph jumps from one y value to a new y value. That's right, from the y value here of 6 to the y value, it looks like these are counting by 2's, to approximately 1. So it jumps from 6 to 1, thus it's called a jump. We have a jump discontinuity at x equals 3. You label these by the x values, for the record. And so finally, we come and we have one more break between these 2 points. This would be an infinite discontinuity because at this spot, the graph is breaking and going to infinity. We would have an infinite, or it would have a vertical asymptote in between. A lot of times we place it that way, but that would be an infinite discontinuity at x equals +4.